The molecules of a strong acid completely ionize in an aqueous solution to produce hydronium ions. And we can see this better using the shorthand notation. And here we have sulfuric acid dissociating into protons and sulfate anions. So therefore, for example, if we're given the pH, then we can use that to calculate the concentration of hydronium ions in the solution. And then using the mole ratios, we can easily calculate the molar concentration of sulfuric acid. And common strong acids to be familiar with are hydrochloric, hydrobromic, hydroiodic, and we have perchloric acid, nitric acid. So we call these monoprotic acids. And the other strong acid to be familiar with is sulfuric acid. So this here is polyprotic because there's multiple protons. And specifically this one's diprotic because there's 2 protons. Strong bases completely dissociate to produce hydroxide ions in an aqueous solution. And for example, if we're given the pH of the solution, then we can use the following relationship to find pOH. And then from that, we can obtain the concentration of hydroxide ions in the solution. And then using the mole ratios, we can obtain the concentration of sodium hydroxide. Now the common strong bases to be familiar with are the hydroxides from the alkali metals and the alkaline earth metals. So from group 1, we have lithium hydroxide, sodium hydroxide, and potassium hydroxide. And the strong bases to be familiar with from group 2 are calcium hydroxide, strontium hydroxide, and barium hydroxide. And you can use the group in the periodic table to determine the charges on the cations, where the hydroxide anion has a -1 charge. A 25 ml 0.05 molar aqueous solution of sulfuric acid is added to 100 ml of distilled water. What is the pH of the final solution? Well, being a strong acid, sulfuric acid will fully dissociate into hydronium and sulfate ions in an aqueous solution. And given these values, we can find the number of moles of sulfuric acid in the original solution. So 0.05 molar or moles per liter multiplied by the volume of the solution. And therefore the molar concentration of sulfuric acid in our final solution is the number of moles divided by 125 mils, which is 0.125 liters. So that gives 0.01 molar. And for every mole of sulfuric acid, we have 2 moles of hydronium in the solution. So therefore the concentration of hydronium is 0.02 molar. And from that, the pH of the solution is minus the log of the concentration of hydronium ions, which gives a pH of 1.7, where the number of decimal places is equal to the least number of significant figures in the problem, given we used a logarithm.